Summarizing categorical data. When a sample consists of qualitative or categorical data, then the information can be summarized by creating a table or by creating an appropriate graph. Okay, and we'll talk about pie charts and bar charts. So remember, qualitative data and categorical data are really the same thing, right? They're just two different terms. So what we're going to start with is, let's say that we had this data set where we observed the gender for students in a classroom. So the first thing we want to do is look at, okay, what is our what's called sample size? How many observations, how many students did we observe gender for? Okay, so in this case, you have 4 in each column, and there are 6 columns. So 4 times 6, there are actually 24 observations in this data set. Now, how many of those were male? Well, let's see. There's 1, 2, 3, 4, then 5, 6, 7, 8, 9, 10, 11. So 11 of the genders were male. And then that means if we go back, we could either count or we can do subtraction, 24 minus 11. I would suggest doing the counting. That way, if you've messed up on the 11, maybe you will catch it, right? So let's count the females. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So there were 13 females in the data set, and 11 plus 13 is indeed 24. Now, there are 3 types of tables or graphs that we can do. We can do frequency, which just means the count. So that would be the 11 and the 13. There's what's called relative frequency, which is the ratio of part to whole. So 11 out of 24 and 13 out of 24. And we could write that either as a fraction or as a decimal, and then percent. And in the percent, we're going to write basically the relative frequency multiplied by 100, and then write the percent sign after it. Okay? So in our table, if I were making a table of observations, what I would do is say, okay, these are gender of students. So I've got male and female, and the frequencies would be 11 for male and 13 for female. Okay, so let's center that. Make sure these are centered too. Now, for the relative frequency, what I want to do is I want to put in sort of the fraction. Okay, so you can use an equation editor, type thing to do this, and then I'm going to put in 11 over 24. Okay, or you could just write 11/24. That would be okay too. And then down here, what I would do is put in the 13 over 24. Okay, and if you were, writing this by hand, it's much simpler to write by hand. Let's see. Now I'm not going to worry too much about the layout here, but I did want to sort of center it. There we go. Just makes it look neater there. So the relative frequency would be 11/24 for males, 13/24 for females. Okay, now the percent, what I would do is pull my calculator out. I would take 11 divided by 24 times 100 and hit equals. And then I'm going to round that off to the 10th digit. So in this case, I get 45.8%. And then for the females, 13 divided by 24 times 100 would be 54.2%. Okay, so this is what I would do to sort of summarize my data. So I went from a list of 24 different observations down to a table that had the different outcomes, male and female, and then either the frequency, relative frequency, or percentage. Now, how could we create a picture that represents this same information that we have in the table? Well, there's two common ways that we do this. One is a pie chart or a pie graph, and the other one is a bar chart or bar graph. Now, a pie, think of it as just being a circle where whatever percentage the category contains is the percentage of area from that circle which you attribute to that category. Now, most people are going to use technology, some sort of software program, to draw all the graphs and stuff nowadays. Okay, I actually have a package called StatCrunch. You can actually rent a 1-year access for, I think it's $8 or $12 or something. So it's not real expensive or anything, but that's what I'm going to use to make a lot of graphs and do a lot of summary statistics and stuff for the course. But a pie chart is going to take the circle, and the way it does it is it actually, if you remember from geometry, the center angle in a circle is 360 degrees. So what it would do is take 45.8% of 360 degrees. It would draw an angle, okay, in the center with that many degrees, and then it would call that the male slice of the pie. The 54.2% of 360 degrees would be the angle measure for the female slice of the pie. Okay. Now, in the pie chart, okay, what we have is this is drawn. You can see female is over half, male is less than half, and it's given in different colors, blue for female and red for male, and it just makes it stand out. The 11 is the frequency, as is the 13, and then the percentages, they went to actually hundredths digits, so 45.83% and 54.17%. Okay, but this is visually what we have written out in terms of numbers in our table. Okay, now what about a bar chart? What a bar chart does is it lets each outcome, right? In this case we have two, one for male, one for female, be its own category. There's space in between rectangles, and then the height, or if you turn it sideways, the length of the rectangle depends on how common the category was. So a category that was more common will be taller or wider, but let's just go with vertical bars. So the width is going to be the same. So the width of the male rectangle and the width of the female rectangle are going to be identical, so that we're not misleading people in terms of area. And then the height is determined by the frequency, 11 or 13, or the percentage, or whichever term that you use. So in this case, you're going to have a separate rectangle for each category. The widths of the rectangles will all be the same, and then the height depends on the frequency, the relative frequency, or percent, whichever one that you use. The more common the category, the taller the bar is, okay? And the bars are going to be separated naturally by space just to make it easy to look at, okay? So if you look down here, what I've done is created two bar graphs. So the bar chart for gender among students for the first one. Now this one, females, right, taller bar, there were 13, and this was frequency, okay? Whereas the males had a frequency of 11. Again, same data. Really, the graph looks exactly the same, except the scale is different over here on the vertical axis. This is percent now. So what I'm doing is using the percent value. So if you go back to the table, I've got a 54.2 and 45.8, right? So you can see that the females have that taller, 54.2. The males have the shorter, it's less than 50%. I think it was 45.8%. Okay, but bar charts are useful when you have lots of categories, maybe 5 or more categories, and then it's easy to look across the top to see which things are more common or less common. Pie charts are useful when you don't have a lot of categories, because if you have a whole lot of categories, those really small pieces of pie are hard to distinguish, and it's hard to see which one is bigger or smaller than another. In this, we can glance real quick, see that the blue or the female category is the more dominant out of the two. And then even if we didn't have the numbers over here, we could still say that females were more common than males in a very quick glance. Okay, so what you're going to have to be able to do is read a pie chart or a bar chart for quizzes and tests and such, not really produce them. But when you're practicing, I think that the ALEC system is going to ask you to actually create some things just so you get used to how it's created and why one category, is larger than another. And that's because it's more common. You had more of those outcomes show up for that. But this is pretty much all that we do in terms of descriptive statistics, in terms of summarizing qualitative or categorical data.